Hey everyone, Anthony here, and today I'd like to talk about Topnode. Essentially, it's a gateway into me explaining a bit about recursion, so hopefully this will make sense. As a brief refresher, for anyone who's not used it, I suspect there aren't many of you, but make no assumptions because not everyone's had to use Topnode. Let me just clean this up quickly. All right. So what Topnode is, it's a TCL function, not Python, which is why it's really handy for us right now. It's a TCL function that will actually walk up the node graph, and I'll reconnect that quickly, in order to tell you what the topmost node is. And what it means by topmost node is not the highest. So if I put this here, color bars is not the topmost node for viewer 1. It's actually checkerboard 1, because what it's doing is it's following the B stream. It's the furthest node in terms of nodes away from you on the B stream. So let's have a quick look at this. For starters, we're going to do pure TCL. So the command is topnode, and topnode does take a parameter, but we're just going to ignore it for now. This is the most common form, which you'll see. You'll just see used here. So this node is 18E8 some number. That's actually the node's internal name. The pretty name is noop1. So let's actually ask for it. So name, value of the top node's name. So noop1. All right. Now we're going to use the noop as a probe. I'm going to chuck it into the merge2. The label is cached. So if you're wondering, when you do a frame jog, obviously this will be updated. But if you're just doing input connections, it's not going to update the label because otherwise your UI would slow down horribly. So you kick it by just changing it. So the noop1 here is saying the top node it sees is blur1. So it's merge2. We'll disable that one just to make it really obvious. Blur1. Blur1's got a mask input, which means there's nothing here. So it is the topmost node. All right. And we'll have a look at scene. So this is more commonly what you're expecting possibly to use it for. So in these cases here is like whatever, that's not exciting. For the scene, however, most likely you will have this setup where you will have a camera that's driving multiple things. Like you could have your scanline, you could have a couple of scanline renderers floating about, and there's your camera there. So there are dots that you're going to be using to try organize your script, or you'd have this dot as plug camera in here, Oh God, here, there you go. Yeah, that's the kind of node you'd have. So you'd have these dots everywhere. Now, obviously on the knob, you can do more than just get the name. We can get the focal. So you can get the focal, which is for some reason I've got a 9.5mm lens here. I must have been mucking around earlier. If you didn't use Topnode, you would have to do something silly like this. I don't know. This dot input 0, I guess. Oh God. Input 0. I've forgotten my input TCL. I half remember. I barely use it, so that's why I don't remember that one. So anyway, this means that this can go anywhere, and it's going to pick up correctly the topmost node, which you're going to define as the camera. Or it's the node at the top. So generally, it's like a read or something, and it's mainly used to skip past dots. Now, if you're wondering, all of this TCL is present inside your Python, your plugins directory. So let me just find that. Give me a second. Here it is. All right. So this is your plugins area. So it's on wherever you've installed Nuke, and there's a plugins directory. And if we scroll down, scrolling. Oh, we're scrolling because I probably should have just pressed the letter T. You'll actually notice a bunch of these things here, like sphere object is gizmo, spot is can't remember what that is actually, but topnode here. So topnode is just a TCL file, and we can just open it and just have a look. So there you go. It's just TCL. And actually something you'll notice is if you've been following the Python stuff and you've been able to start getting into the headspace of what this means, this outside of this section here, this probably looks relatively straightforward. Like, you'll recognize some of these things. Proc is short for process or procedure. I think it's procedure, which is equivalent to the def function. So you notice that it's got the same kind of idea. Hey everyone, this is a function or a procedure. We're calling it Topnode, and we're going to have some arguments with parameters we can place in here. Once we get into the curly braces, that's the function. You've got if statements, so conditionals. If the argument's blank, then do something, otherwise else, do something else. This probably looks a bit confusing, but keyword at the start, for, it's a for loop. So if you could read TCL fluently, you'd probably just go, yeah, sure, for loop, great. And then a return statement. So once you're done with all this malarkey, give me something back. So we're actually going to be replicating this in Python right now. So let's clear up and let us do this. Let's do this in the simplest possible way. All right. So the first thing we're going to do is we're just going to start with, by the way, something I should mention. What I have on screen right now is actually a very primitive but quite a useful test case. I know that if I plug in merge 1, then I'm expecting checkerboard 1. If I plug in merge 2, I'm expecting blur 1. Scene 1 is going to get me a camera. So I have 3 known inputs and 3 known results plus a bunch of noise. It's not a very good test case, but it's better than nothing. So it's allowing me to actually have a test whether or not my code works. So we're going to do it quickly, just for sanity's sake, and also so you know. There is this thing you can call TCL from Python, Topnode. We do the same thing. So Nuke TCL Topnode. Probably should do that one. Topnode on merge 2. All right, so it's this weird number. Like we did on the no-op, you can then ask for the value of its name, like its nice name. Veil hasn't died yet. Blur 1. So merge 1, just change that to merge 1. Cool, and checkerboard 1. So if you do need to execute some TCL, if you didn't feel like writing a Topnode procedure or Topnode function, just use Nuke TCL, you're fine. But since we're here doing Python, we might as well do it. So, much like we did before, we're going to write a function that does this, but we're going to do it the dumb way to begin with. So let's look at scene 1. We're going to take the node, selected node, and then we're going to be, let's call it the node. All right, so the node. Now, doing it by hand, our finishing condition is when there's nowhere left to go. All right, so the node input 0. Let's just do this like a machine. We've gotten the node, input 0. Okay, it's a dot. We've still got somewhere to go. Still a dot. Oops, too much. Still a dot. Still a dot. Camera. Nowhere to go. So therefore the answer is this one here. So it's a 1, 2, 3, 4, 5 in. All right. This looks very much like a loop. It's the same repetitious process we do over and over again. We stop when the result is empty. And that's because if you remember from previous videos, the input call, you can ask any node in Nuke for its input and it's not going to explode. It's just going to simply say, you've asked me for the 20th input. I've got nothing, none. And that's actually perfectly fine. So let's write our function now with this primitive manual process. Right. So we would say, let's define our function. Let's call it Topnode. And we're going to take a node. So the node. We, as always, we write our doc string, return the topmost. There's a rule, you shouldn't use the same word to describe it. Return the, I'm just going to use topmost. Most node on the B string input 0. Right. Cool. So that's what we're going to do. Now, this loop here is slightly different in terms of we didn't know how far to go. We actually just had to keep doing it until we hit a brick wall. So we're going to use a while true loop, which you'll see my reaction. While true. So if we just printed hello, don't run this, by the way. This will print hello, and then it'll check if true is true, and then it'll print hello, and it'll check if true is true, and it'll print hello, and it'll repeat this until you get bored, the computer explodes, there's a power cut, or you just kill it. So while true loops, but we'll do it in this case. So basically, we're doing what we did before. Keep doing this forever until we hit the reason we stop. So the node input 0, and the reason we stop is if there is no input 0, then we stop. In this case, we stop. Oh god. To be honest, I always do this. It's I hate these kind of things. Yeah. Let me modify this slightly. Current node. New node. All right. So we actually need to walk up the tree. So we would start somewhere. We go here. We choose the direction. We're here. We're here. We're here. So we actually have this concept of where the current node is. If you've programmed C, imagine that's a pointer. So we're saying the current node. If the current node, we'll do it explicitly, is none. You wouldn't do it like this, but for our purposes. If the current node has no more inputs, we are done. Stop. Return the current node. So the current node is as far as we can go. Okay. If the current node has an input, so if this statement's false, this up here, right, then else current node equals the current node in input 0. So if you can go somewhere, if you've got an input 0, well then make that your current node. So in this case, if we go through this by I guess by hand. So we'd start at merge 1. We'd say the current node is the node. Okay, cool, enter the loop. Do you have an input 0? Yes, we do. Okay, cool. Make that your current node. Now go to the top, loop again. Do you have an input 0? Yes, I do. All right, well, cool. We'll make that the current node. Do you have an input 0? Yes, I'll make that the current node. Do you have an input 0? Yes, I'll make that the current node. Do you have an input 0? No, I got nothing. I am the end of the line. Sure, you are the end of the line, return the node. And that is basically what we've done here. So let's just verify this works. I'm pretty sure it does because I don't spot any obvious mistakes, but let's make sure. Topnode, and we're going to use that one. So we'll go for, yeah, let's just use that again. So Topnode of the node. And we'll put that, print out Topnode as name. Here. Checkerboard 1. Great, let's look at this guy. Selecting the node, printing it, it's going to be blur 1, so it is correct. And for the last test, scene 1, error 1, awesome. And we can even modify it, plug the axis, oops, plug the axis in here, and it's axis 1. If you haven't done this, by the way, same trick applies on pretty much anything. If you disable it, disable the node, what it lights up is your input 0, if you're ever curious. So obviously not the mask input. So that's actually pretty straightforward. You now have, I'll post code as always, so don't worry about copying this down as I yammer away, but you now have a working copy of the Topnode function. You could do other magic here if you wanted to. You could have a maximum depth, max depth. You could say none. None means infinity here, so let's update things. Go at most max depth. If none, go forever. Right. So again, we can augment this. This is something that you could also probably do in the TCL, but we're going to do in Python. So max depth is none. All right. What we're going to start doing is we're just counting. So let's say max depth is let's do here 1, 2, 3, 4. Let's do 4. Okay, so let's assume we want to go for 4. Top node, the node 4. So we only want to go 4 levels in. So in this case, the go at most max depth, and then return that node. So it's not going to return the top node. You would rewrite this thing, but it return that node that you found. I'm sort of modeling behavior that suggests that bad doc strings like this while we're working is better than no doc strings. So do them roughly, make sure you remember what you're doing, and you just go, ooh, I forgot something. And then make sure to come back and polish it up later. But, you know, if I was going that one because I thought, oh, I don't know how to phrase it properly, I'm going to forget in 20 minutes. When I try another take of this video, I will forget, and yeah, bad. So to do that, we need to count. So the current node, depth equals 0. Let's do it that way. Depth equals max depth. I can't think of a nice way to do this actually. We'll just count up. All right, so depth is 0. If it finds something, great, we're done. Else depth plus equals 1. So add 1 to the depth. This here is that's completely equivalent to depth equals depth plus 1. We're lazy, so we find shortcuts. So I didn't want to type out depth twice, and adding 1 to a variable is very common. So we start at 0, do this, and we also need another termination condition. So if the current node is none, then return it. This is one way to do it. Else if the depth is greater than max depth and max depth. I should write the other way. Else if max depth and depth is max and depth, then return current node. I've would normally compress these into the same condition just for clarity, but equally I would argue that this is probably not a bad thing to do. This so you can see each termination condition. So we're only going to go about 4 nodes. Let's just try that. 1, 2, 3. What have I broken here? Oh wait, selected node. Okay, so the selected node scene 1. Yep. Okay. Cool. As evidenced, I tested my code and I found it wanting, kind of. My user input was wanting. So it's only gone up 3 nodes. So from here, this is 0. This is 1, 2, 3. This is .1, and it's gone to this guy, which is .4. So I potentially have an off by 1 error here. It depends on what I mean by 3. Because if this is the 0th, it's going to say maximum 0, 1, 2, 3. That's fine. If I define this as 0, that's 1, 2, that's the deepest it should go. So that's a definitional problem. So let's go at most max depth nodes. If none, go forever. Return the node that you found at this depth. Go at most max depth nodes, and for ourselves, note the first node. No, we'll just say the first node found is depth 0. So as you can see, I've gone back and polished it up with something I just found out as testing. It's like, oh, I probably need to put that node in here. In a normal world, I go and clean this thing up massively to make it make more sense for me. But yeah, that is a very simple top node plus a variation on top node to do a max depth. You can change and add other parameters there. Like for example, you could say on switches, always go to input 1. On cameras, always stop. Like you could make hybrid top nodes where you could put another function here, which is a termination condition. So you could, because you can see the axes is actually an example of one thing that you can do. So you can have an axis driven by this guy. You may actually just want to not get the top node, because top node's going to get you to the camera 2 right now. You may actually want to get the first camera that is above the scene node. So you'd modify this thing here to actually say your termination condition is not a depth-based thing. Your termination condition would be, hey, did I find a camera? Oh, great, I found a camera. Stop now. So again, you could modify this to your heart's content. So that is the straightforward way of doing it. Now, we've got, yeah, this is dragging on a bit long, but let's see how quickly we can do recursion. All right, so Recursion is interesting because let's bring this down quickly here. Right, it's a bit of space. So, unlike the regular for loop, which you would have seen, so okay, I can't use a for loop here. Let me just pause the video and turn the lights back on. Okay, yeah, you can tell it's getting late when my lights automatically flick off. But here we had to go forever because we didn't know where to stop. So this is not a for loop. A for loop looks like this. For x in range, range 0 to 10. Do something, print x. All right, that will print the numbers 0 through 9. Because the range here has a defined start and end, you might not know until you look at it, but there is not a, do you have one more? Do you have one more? Any more? Like, you don't have to keep testing it. There is a defined end to it. This structure here, on the other hand, let's get rid of those guys. This, on the other hand, with more dots here, we don't know how far we need to go. We basically need to go until we stop. And you can see this is what we've done here. We checked, is there an input? Is there? Like, we keep going further and further. Unlike the for loop though, you'll notice that we're operating on itself. So if I put bracket, oh, well, I wouldn't even put brackets in. We're just saying the node's input, check the input of the input, check the input of the input of the input of the node, check the input of the input of the input of the input of the node, check the input of the, you get the idea. This is a prime candidate for recursion because we're doing the same thing to itself in essence. So let's try this again. So we're going to do Topnode, node R, and we're going to take the same argument, which is the node, right? We're going to have the same doc string here, so I'm just going to take that first guy. We'll worry about the rest later. So that it does the same thing. Now let's write this slightly differently. Okay, so recursion always does my head in, so bear with me as I remember how to do this. So you want to check the node. You want to check input 0. So our condition is let's do that again. Yeah, let's actually take that as well. Yeah, all right, cool. I think I know what I'm doing. The current node is the node. If the current node input is none, return the current node. That's not particularly special. We would have seen exactly the same thing here. Note this isn't in a loop yet because we're not using a loop. We're not going to use that particular kind of flow control. What we're going to say is, okay, if your node has no input, you're done, finish, you're the checkerboard, move on. But what happens if it does? So current node does have an input 0. All right. Well, we're going to do this. Return top node R of the current node input. That's gonna look slightly weird to you potentially, but let me explain what we're doing here in Nuke terms. So if I have a viewer here, the viewer is simply trying to display an image. So the way it's displaying an image is it's saying, hey merge, can you give me some pixels? I'll disconnect him for simplicity. The merge is saying, sure, I can give you pixels, let me ask my neighbor. Transform, give me some pixels. Transform, sure, I can give you pixels, let me ask the grade. Grade, give me pixels, all the way up to the checkerboard, where checkerboard's been asked, hey, checkerboard, give me some pixels. Checkerboard's like, oh crap, I'm it. All right, I've got to give you some pixels. And then it starts sending pixels all the way back down the line. You'll notice how similar this is to what we're saying with Topnode. Hey, do you have an input? Yes. Hey, do you have an input? Yes. And rolls all the way to the top. What we've done is we've basically replicated it here with the differences that this function doesn't actually care about how far it has to go. Like in this version here, we can actually have a max depth because this will just count up one by one. You can actually do it with recursion, but just for now, bear with me, we'll get there. With this one, we're saying if you're supposed to stop, just stop. If you aren't supposed to stop, don't bother calculating everything. Just run a new copy of the function. And this does actually work. So let's actually What did I stuff up there? Unindent does not match any outer in. Oh, did I have 5 spaces? No. What have I broken here? That was weird. I must have had a tab character or something. If anyone can spot that on the replay, let me know. I'm quite curious. So Topnode R, we're just going to use this again. So Topnode R is the recursive version. Print Topnode R dot name. So, oops, for the selected node is scene 1, and the top node is camera 1. Selected node here. That's fine. That won't make any difference. Is checkerboard 1, and merge 2 is blur 1. So this is recursion pretty much. It is a bit of a confusing topic in some ways, but what you're seeing here is one of its applications, and same thing with the Nuke node graph. In a Nuke node graph, every node does not care about any other node. It just simply asks, hey, give me pixels, give me information. What's your bounding box? Do you have metadata? Sure, pass it down to me. It doesn't care more than one node in. It makes it very simple to build complex node graphs. Like every one of you who's done any comping will know how complex these things can get. But if you looked at each individual node, they all do one thing and do it really well. The grade grades, the transform transforms, the merge merge, the blur just makes a mess of everything. Right? They all do one task very well, and it makes them easy to plug and move around and do stuff with. Same idea with recursion in a way. If you can boil down your problem into something really brain dead, like this, just get the input over and over again, you can write relatively elegant functions like this that really express what you're doing. Now, you would have noticed back when I was writing this thing here, I was going, ew, I don't like this kind of thing. The reason is because this, if you get this wrong and you don't have termination conditions here, if you stuff something up here and it never can exit, this is going to run forever and it'll never stop. So out of habit, I tend to put in, anytime I have while loops like this, I tend to put in a maximum depth, because I don't necessarily trust the fact I haven't dealt with all the edge cases. I will stop at 99 or something that I consider a reasonable limit while I'm testing. Otherwise, I keep locking up Nuke. Recursion also has the same problem. In fact, let me quickly demonstrate recursion as a problem. So treat this as it works. Again, source code will be in the video. You can play around with it, but let me show you how it breaks and when it breaks. Def foo return foo. That is a recursive function. That's bad. Right. It will complain at you very badly like this, because foo is running foo, which is running foo, which is running foo, which is doing it several times. You can see that it's complaining about the function, and it's saying recursion error, maximum recursion depth exceeded. There are many reasons why this is a bad thing, recursion in this case, because your stack gets exhausted. Heap or stack, I keep forgetting. It's been a while since I did comp sci stuff, but there's a limit to how far this is sensible. So that's how you'll break recursion. But when you can get away with it, when you can understand it, it really creates quite elegant stuff. So this to me here, this recursive version, is much more readable than this version, even if I get rid of this max depth stuff. Like, I can read both equally, but I find this a more elegant explanation of what I'm trying to do. I'm basically saying, get me the current, check if you got anywhere to go. If not, great, you're it. If you do have somewhere to go, can you ask that node, can you please tell me what that node says, and then you run that function again, and it just runs it over and over again. So yeah, hopefully this makes a bit of sense. Recursion is one of those kind of fun topics. When you first write this out, I think this is take 3 where I've tried to do this, and every time I do it, even though I'm doing exactly the same thing, and I've done this many times before, I just have to scratch my head. And I almost go through this process in a very similar fashion. Recursion can be quite complex because of its nesting. It's things doing things to themselves. So I will write stuff out like this and just go, does this match the problem I'm trying to solve? I won't immediately say, hey, it's a recursive function, let's write recursion. It's like, maybe it's not. Maybe I don't want to write it like that. So it's if you can get your head around it, it's another tool in your tool bag. If you can't get your head around it, that's fine. It's no biggie. You can replace it with things like this. This is no less elegant. It just expresses in a way that I think slightly differently. So use what works. There will be cases where trying to write this way with a infinite loop may actually force you to approach the problem in ways that are going to be harder to phrase in code. And there are times when phrasing it in recursive form will also make you twist yourself in ungodly knots trying to do it in this fashion. So choose the technique that works for you. And as well, if you don't want to write any of this stuff, just use the TCL.